Hi everyone, thanks for joining us today for new Apple Silicon, when to migrate to the M1 Mac. I'm here with Chris Chapman, Chief Product Officer and SVP of Software Development, who will be leading this webinar. Just as a reminder, you will be muted for the duration of this webinar. If you have any questions for Chris, please put them in the chat or questions pane and we will get to them at the end of the webinar. We will do our best to answer all questions, but if we run out of time, we will get back to you after the webinar. Now, without further ado, I'm going to hand things over to Chris.
Thanks, Stephanie. Hi, everybody. I'm Chris Chapman, as she said, Chief Product Officer and SVP of Software Development for MacStadium. For those of you who don't know, MacStadium is and has been the leader in providing Mac infrastructure at scale for the last 8 years or more. And we're a company focused on providing Mac cloud solutions and services for orchestration and delivery. And we have a global footprint for enterprise class services. So we are all about Apple all the time. And today we're really excited to talk to you about Apple's latest platform and how this affects development and, quite frankly, the future for everybody. Quick housekeeping note, we're going to provide follow-up blog posts with all the links that you'll see in this presentation, as well as the recording of this webinar and anything else you might need, so no need to frantically screenshot or feel like you have to be distracted to catch some content. We'll make sure you get it. So let's dive in. M1, that just happened, right? I got to tell you, we follow Apple. Obviously, it means everything to us, and we were as shocked and as excited as everyone when they not only shifted to the ARM architecture, but they shifted to it for the Mini, which is something that we rack and stack all day long, and that was a pretty incredible thing and a pretty incredible opportunity for us. The reason this matters a lot is this is the first time in a long time that the platform for Apple has changed at such a dramatic rate. The last time was a decade ago or more when they moved from a PowerPC to an Intel architecture, and that opened a lot of doors for a lot of things that created the world we live in today. And this is another tectonic shift, and it really represents Apple's evolution to where they're creating the best products for their customers that is the blend of hardware and software. So shifting to their own silicon means a whole new architecture from here on out for all of us, but it gives us so many things. Just off the jump, this 64-bit ARM architecture is so performant, and even these first models we're seeing have 2 times CPU performance, 2 times GPU performance, and 3 times the average performance per watt from a power perspective. And I know that's a little bit on the nerdy data center side of things, but even in your hands in a laptop, it's a quiet, cool, high performing system, and it's really, really incredible the way it can run software, even the software we have right now. In addition to that, again, the Apple experience is the combination of the hardware and the software, and Big Sur also was released in preparation for this platform, and it's a next generation OS. In case it was lost on anyone, we went from a 10 to an 11. I mean, that's a major epoch of Apple OS, and it was intentional because it brought a ton of features geared towards the new platform, but it also baked in a way to bridge the past and the future. So we are now running an OS that's optimized to leverage the compute of this new platform and also give us a way to take things from the old world to the new world. And one of the big things they baked in was real-time emulation, and that helps bridge the gap from Intel to ARM. It's going to surprise you how well this emulation actually works. Obviously we'll get into it in a little bit about how that performs and what that really means, but it's often eye-opening when you run things to see, because of the difference in hardware capability, what that does to your software. Additionally, Catalyst and the continuation of Catalyst helps you bring your iOS and macOS applications interoperably between these two platforms. So this really is a well thought out plan by Apple to give you all the tools and the technology you need. Now, granted, we're going to get into how we're all catching up, and of course, when you drop an entirely new architecture with an entirely new OS on the world, it's going to take a minute for everybody to get their head around it. But the cool part is that the tools and the pathways are there. So this is what we're going to cover today. This is what it means. And it's the questions that most people that we talk to have. It's, hey, cool, this is awesome, it's super fast. Can I move everything now, and what do I need to know about that? Where are we now and where are we going with ARM and Intel? How does the software work on this stuff? What issues am I going to have? What progress and challenges do you see in this ecosystem? And there's some rumors about virtualization. What is that all about? And how do we stay ahead of this? And then we'll get to questions at the end. The good news about this platform really is it's exciting new hardware and OS, and it unlocks this massive potential. The bad news is that as software users and especially as developers, the race kind of starts now for us to utilize that platform. So there is time that it's going to take for us to convert and catch up to get all these new technologies working the way they're supposed to. Apple, I believe, has a really solid plan that in the next 2 years we're going to be transitioning to this 64-bit ARM architecture. And when I say transitioning, I'm saying the end game where all things are this ARM architecture versus the mixed world we live in now. So that being said, we do live in a world where it is a transition point. So you've got to get tooling and planning and coordination around balancing these two platforms. So we're going to get into the details now. Again, talk about what you need to know, talk about Rosetta and emulation, talk about desktop applications and CI/CD tools, get into what you're going to do with mixed environments and how to keep your legacy and future things working pretty nicely side by side, and how you can adapt so it's not one big crazy uplift when you get there. So the question is, can I move everything now, and what do I need to know? Well, again, to be definitive, it kind of depends. The platform is Apple. It is working for Xcode extremely well. For Mac OS and iOS apps, it's a no-brainer. Builds with Xcode are going to work great. They're going to help you build your applications and run as fast as possible. But then as you get into CI/CD and larger build and technology chains, you're going to find that complexity brings uncertainty. And that's because we're starting to have to adapt to the ARM platform and change all our libraries and dependencies and technology chains to fit that. So it's the more components you have in your process and the more applications or scripting or libraries involved in what you do, the more uncertain it's going to be as you start to try those tools out on this new world. One of the blessings and curses is emulation is available, and it's so good that it practically just works for so many things. You'd be surprised when you put an application on this platform how well it runs and how often it just does run. That said, as you get into complex applications and emulation, there are caveats and gotchas, and they can sometimes mask things that you're not aware of until you run through them. The other piece of this is that our productivity and our development tools are catching up, but they're catching up quickly. But a lot of the well-known development platforms outside of Xcode are obviously trying to move as quickly as they can to move past just working in an emulation mode and working into a native mode. And again, they run into the same thing where their dependencies are often upstream from them, and they'll have to work with those to get their tools working. And I guess the sticking point here about it, can I go or can I not right out of the box, is if you're running Xcode and Mac OS and iOS apps just straight in Xcode, it's probably a fairly safe bet that you can jump on this right away. But as you increase your tool chain, you're going to need to test it and find out where the sticking points are. So let's talk about the future and the present, right? Again, we're living in this mixed mode. 2018 and 2020 Intel models are still produced. They're still very powerful. They're obviously very recent. We use them all the time. And all your software tooling and your software CI/CD chains are going to work completely end-to-end on Intel models like they do today. As far as compatibility goes, depending on your application, if you're backward compatibility testing for Mojave or Catalina or some other types of situations, the older platforms are going to have that wide scale compatibility because they can handle those operating systems and those compatibilities. And also, I guess a note, as you're starting to look towards this ARM architecture, it's good to know that, again, Big Sur was purpose built to help you make this transition, and they provide a way to build for the ARM platform target. So you have a way on your existing Intel architectures to start building and practicing for the ARM platform and then testing it out. That said, that is the past and the present, but the future is ARM. It is going to be where we are, and the best way to test your features for Apple Silicon is on the actual Apple Silicon. So you can build your targets and you can have them be ready from Intel, but as you go through debugging and things like that, you're going to want to try it out on the Apple Silicon to see how it actually works. And the other thing to note is that Big Sur and anything beyond Big Sur is optimized for this ARM architecture. So to get the true power and capability of the hardware of this platform, you're going to want to be on it and on it with that OS. The other good part, again, software is really on a solid path with Rosetta and the ability to create native applications. So I think you're going to find that, as daunting as it sounds to sort of retool everything, that it's going to happen quicker than you expect. I think for us, that's what we've started noticing in the ecosystem. Again, we were surprised and excited and then kind of ready to get to work when we saw the platform come out, and have some long poles in the tent and short poles in the tent as far as development and getting our own systems up to speed. But we've been a little bit surprised and delighted to see how quickly things have been converting over and how quickly tools have begun to work. So let's talk about software on the new platform. Let's get into the details of that. Native applications, again, like Xcode, will work well, and they have significant building power. They run very fast. Native applications for Apple, like Pages, Numbers, and etc., those things work great. They're Apple software, of course, they're going to work great. Native Apple development tools for Xcode, iOS, Mac OS, etc., they all work great. Python has been converted and it runs natively and well. And if you're doing any kind of front-end web application development, just HTML5 and JavaScript, CSS, that kind of thing, it will not have a problem. Those are obviously fairly simple and not back-end intensive. They don't depend on a lot of other things to run. And as you can see here, you start looking at capability and by configuration and build time just on some rough benchmark numbers, and take benchmarks with a grain of salt, of course, but these are probably just examples, but representative of what folks are reporting across the platform, which is significant improvement in speed and power from a resource to processing capability. So what makes some of this stuff easy to start testing? Let's talk about Rosetta. Rosetta is Apple's emulation platform, and it's basically translating at runtime your x86 instruction set to ARM so that your application can still work on the new platform. And it's really efficient and transparent. And again, because of the hardware differential, speed and performance are often better than you expect. We all know there's computational penalties for doing extra work. Obviously, emulation's having to do translation of instruction sets, and depending on the app or complexity, you can see and notice delays as this happens. But again, it's pretty snappy, and you'd be surprised how quickly, even with that differential, this platform runs. Sometimes it feels like your app is running equal to or better than it did on older hardware. The challenge here again is you start getting into complexity, you can get delays and crashes in parts of the application you may or may not expect. And that being said, and for all the greatness that this has, you need to know that emulation is not a substitute for native applications, and it's not a substitute for taking advantage of universal binaries, which is what we're showing here as well. Universal is the way to basically create a target specific application while you're building on whichever platform you're building on, and it really helps you sort through what you're having to do to get a fully native application up and running. You can turn all your code into universal binaries, and that should include extensions and plugins and static libraries, dynamic libraries, daemons, etc. And going through that exercise, it will help you sort out pain points or areas that may not be working the way you expect them to. One thing to note as you start to go through these exercises is that when we're talking about Rosetta and how it emulates, there's this sort of a concept of chaining. Rosetta applies to the whole application process. So it takes all of the x86 components that you're going to need to emulate and emulates them for the whole process. That means as you get into these applications where you may or may not be aware of extensions or third-party libraries or plugins, they can affect how emulation occurs. They can cause the breakpoints. They can affect how that chain and dictate more than just your code, what you're going to need to emulate and how you're going to need to wrap that. Emulation also is not going to handle things in some legacy apps that Apple's been warning us for time now that we need to work on doing the right way, which are kernel extensions. Also, and we'll get into this more a little bit later, virtualization or virtualized applications do not emulate. And there are even some newer Intel instruction set and newer instruction set processor features like the vector instruction set that might be in the AVX category that you need to test thoroughly, especially in the emulation mode, because they may or may not be emulated correctly. And those things can affect what your application does in an emulation mode. Like I said, the safe bet long-term is start building universal apps. And you can build those on the Intel platform, and you'll basically be debugging the ARM64 portion of the binary on an M1 platform. That's the right way and the way you'll need to do that. You can debug both slices on the M1 side, so this is sort of a plug for the M1 architecture, in that you have the capability to look at both the Intel and ARM side of a universal app on M1, whereas on the Intel side of it, you're only going to be able to debug the x86-64 instruction set, and you'll have to, again, find an M1 target to get the rest sorted. Just for a note, and Xcode builders know this, but universal binaries are automatically produced for the release of your code, but in debug and test mode, your builds are going to be platform specific. But when you actually build a release version of code, there is a universal binary that is produced that you can take advantage of. Again, you need to work through it to find all the sore spots, but it's there. So what about the software you actually use? Let's talk about actually using this platform. Mac Mail and productivity apps do work, of course. Surprisingly, Office 365, for those of you who use that, it works. The main apps like Excel and Outlook and Word do. The installation can be a little tricky. Microsoft's working on making that seamless and native and capable on this platform. But the best advice you can get right now for that is just, make sure everything's shut down when you run it. I think it just takes a lot of emulation power at the present state, but it can get up and running. Messages works because it's Apple native, but so do Slack and Teams. Those applications for communications work well. Safari, of course, works, but also Chrome is native and they work very well. Other browsers work to some degree, and if they don't work natively, they work in emulation mode. So your kind of daily driver software is available and ready, and you can use it. Zoom, things like that work fine. You can have a pretty solid experience. And again, the platform is so quiet and so fast that you shouldn't have a problem there. Now, when you get into the desktop, of course, again, we've said already ad infinitum, Xcode's fine. And the tools are the best they've ever been on this platform. Other things that folks might be digging into, like Visual Code, work well, but depending on the language and the language support, that's where it starts to get iffy. This is particularly true of software that might rely on Docker or Node or modern web stacks that are full stack, quote unquote, web architectures. And that can lead to dependencies and issues there. Also things like Flutter or Ruby, things like that, there are some upstream dependencies where you may hit places where you're going to have to do a lot of searching or customization because it may not work just out of the box. IntelliJ works great. That's another developer a UI that you can take advantage of. When you get into CI/CD, that's where it starts to get tough. Again, obviously CI/CD is chaining a lot of these things together, and things like Jenkins rely on JVM, Java Virtual Machines. That's problematic. Adopt OpenJDK is hard at work. They're doing all they can to get going on this for the M1 target. Currently, Azul JDK does allow for JVMs on the M1, and that does give you a JDK, but again, that sort of makes installing these things a little clunky. Self-hosted runners like GitHub Actions and things like that aren't yet available. They're working on native targets, but they don't work right now. Remote execution tools like Bazel have asked the community to participate in getting the M1 target ready, but again, they're not available yet. You do have command line tools like Ninja, but you can encounter issues with configurations or dependencies. So as you work through those, you might find unexpected breaks in your stack as you pull things in. And then tools like Fastlane are still finicky again because they depend on Ruby, and clean installs or custom binaries might be required to get that chain working. They have gotten those things working. It just, again, if you're transferring over from a previous device or you're using a previous configuration, you may be required to sort of reinstall or custom install some of these upstream dependencies to make sure things work. And we'll put links, as we alluded to before, to the various repos and boards for these technologies, so you can kind of follow your favorite one and see where they're at in their migration to the M1 platform. So let's talk about progress and challenges with the ecosystem, since we're kind of into it, right? Yeah, obviously several teams are hard at work on implementations. We want to all use this platform, and the progress has been really fast. Some of the most critical ones that we see at MacStadium for builds are CI/CD tooling, and a lot of times there's Docker dependency. Homebrew is a huge one for how we configure and set up Macs, especially as we do repetitive build processes. And then a lot of the world is in GitHub and uses GitHub Actions. So the good news is Docker already has an experimental release for M1 out. It is experimental. They do not recommend it for production. There are gotchas and there are some hard coding things. They're working hard to figure out the intricacies of the OS integration and emulation points. There are parts of this that are emulated and parts of this that are native. There are things you have to do from a DNS perspective with regards to Kubernetes, if you're using Kubernetes on Docker like that, that are tricky. Homebrew has, core M1 support, and they're continually working on improving that. Their goal is throughout 2020 to make this more reliable and more available. They won't state officially M1 support because, to their credit and to their point, the devil's in the details of the casks and the libraries, and it's only until those things get converted over that we're going to be able to really work through things. That's the same position you're going to have in the Docker world. You've got to remember, when you start doing Docker pull on different things, you're pulling in, fully baked dependencies there that could be 32-bit libraries of whatever. And until folks start making the 64-bit ARM equivalent or the converted version of that, you're very likely going to go pull something that is your favorite or dependent thing, and it's going to end up forcing emulation or causing a problem in the chain, and that's where this starts to get tricky. So as frustrating as it is for these folks, they're making good progress. It's just a lot of upstream to deal with as well when you talk about these configuration packages. GitHub Actions are also still at work for M1 targets. They're testing stability and performance on the platform right now. They want to make sure that when you run a GitHub action, you're running it and getting the experience you're expecting to get. So they're still working on that from their cloud's perspective. As far as the self-hosted runners, they don't have that functioning yet. So there's not a self-hosted GitHub runner that you can put on your platform yet. Again, we talked about it a little bit before, but Jenkins on the JVM stack is a dependency, and so the tooling isn't really effective there. And then BuildKite and other platforms often require Homebrew interaction or packages that they use with Homebrew. So they've not only got to get their packages working and the Homebrew part working, but third-party packages working. So there's kinks to work out there, obviously. What I can probably speak to a little more authoritatively from where we are on progress is Orca. I'm obviously pretty close to that. We have a 2021 plan to have M1 support, so we will have support this year. There are multiple technical approaches under evaluation. Obviously, the key for us on that platform is maintaining the Kubernetes orchestration component of that and making sure that we leverage the hardware in the most appropriate way. So whether that is pods consistent with the way we work with the Intel version of it, or whether that becomes a more closely integrated OS integrated approach is what we're exploring in our development right now. Other platforms are also working on a 21 plan to have M1 support. Folks like Anka, they obviously have a vested interest in getting that build system up and going with this powerful new hardware. Another big component, obviously, of build, whether you use a build system or whether you're just trying to leverage bare metal, is the device management itself. In Intel-based architectures, we hear, and other folks have often leveraged things like cloning tools or re-imaging. That ship has sailed and is not a thing anymore. So, relative to putting devices into a clean state, on the M1 platform, imaging is just not an option. So that's something you're going to need to consider as you migrate to this platform. It's not something you can automate. It's not even something you can do as a tool right now. There are some tips and tricks on how to work with the M1 installation process that can help you get over that. Our data center folks have a lot of good ideas there on what we can do with it so far, and that can help make it a little bit easier. But again, it's a lot different than what you're used to. It is possible to do things that are a little different, like boot from an external SSD. But again, that's finicky, and you start getting into the internal drive versus the external drive. But there's a way to do it. Again, I would caution that. It doesn't solve the problem probably the way you want it to, but it is a capability if you're scouring the web and looking for ideas. MDM tools are more appropriate for fleet management. So if it's all internal to you, you may be able to leverage some MDM capability. But again, think of it in the way that MDM is really designed to manage the enterprise desktop for everybody, and it's less CI/CD focused. So a lot of times when you're getting into automation and orchestration with MDM tools, you're going to run into some just technology barriers on how those tools are designed to work and what their best and highest use is. It's just a different problem at scale. So as you go to orchestrate bare metal and you work on your build to get a clean state, you may have to work on some more scripting and some more tooling around how you make sure that the OS you build in stays clean and in a ready state for the next build process. And then, timing. Like I said, Docker and Homebrew already have features ready now to test, and other teams are already actively working on the solutions to have native capabilities within the next few quarters. So I think it's a as we go along this year kind of thing. I would expect the mid to the later half of this year, a lot of the tools will at least have a good V1 ready and capable. And prior to that, like I said, experimental builds and beta builds are available, and it's in your best interest to grab those early and see what they can and can't do for you, so you can find that out sooner rather than later, and also honestly give feedback to the folks that are trying to solve this problem now. It's a whole ecosystem of conversions and dependencies. It's going to take time to convert to this architecture. And I would just say, in general, if you're trying to think about timing, the more complex and variable the components of your build are, or the more types of builds you're running, the more tool chains you have, the longer that process is going to take you, because there's going to just be more upstream dependencies for you to have to consider in this move. So I guess let's get to the virtual elephant in the room. Again, I run the Orca team here. We rely heavily on virtualization. MacStadium hosts VMware. A lot of you folks out there are using Anka. Virtualization is a huge part of CI/CD and how CI/CD works. It allows us to do very quick and agile and ephemeral type things. And that's a big concern for a lot of folks, especially if you're tooled around virtualization. The good news is Big Sur added some much needed development in the hypervisor framework, and this work is continuing. The framework in Big Sur is kind of the beachhead for what I believe Apple intends to be a much more robust virtualization system for Mac OS. The challenge is that virtualization in general has a pretty heavy tax to it. And doing virtualization the right way is a balance. It always is. It is in the current architecture, it will be in the new architecture. So just because you can leverage virtualization doesn't mean you can do it in an efficient and an effective way. And obviously, as we talk about virtualization with the tricky part about that is folks tend to throw things in virtual containers and just throw them on a platform. Well, virtualization doesn't solve conversion or emulation problems, and emulating virtualized things is not a thing either. So that's going to be a challenge as you try to do things like that. Apple did support Linux VMs, and 64-bit ARM VMs are possible with Parallels. They're working on that track to have a 64-bit ARM version of Windows capable of running Parallels on your M1 laptop. That should be interesting and good for those crossover applications that folks are interested in. There are some, and I won't pretend that we don't know about them, open source community and other activities that are very, very interesting. They look like they're actually rapidly progressing the capabilities of virtualization. And I think that has happened quite a bit faster than we all expected it to. Basically, the stance we have on this is that the value of these boundary pushing efforts is in a way good because it helps write extensions and parts of the Apple ecosystem that Apple's not going to focus on as a mainline goal, but it's going to help foster adoption and use cases that don't fit those mainline goals so that we all can get our work done. Just to throw it out there, and again, to get the elephant out of the room at this point, there are folks like Linux on M1 with Asahi, Hector Martin, Marcan, Corellium, folks like that working on graphics and GPU. I will say, with anything that comes with this kind of going around what Apple's already doing, is the danger between getting in between the hardware and the software is you can become unintentional roadkill. And it's not because they're out to get you. Apple is not. They're focused on making the best product they can and the best experience they can, which means they're going to write the best software that leverages the hardware in the best way. And that may or may not be with the things that you're thinking you're getting out of this, off solution. But again, I think the value here is that these virtualization efforts are helping us sort of address and look at things that we're going to need to do virtualization the right way with Apple. It's going to help us sort of push the boundaries of what we need in the hypervisor framework, what we need to do to interact with this M1 platform in a good way. Also, again, virtualization doesn't solve this 32, 64-bit problem with these third-party dependencies. It doesn't solve ARM versus Intel issues. So having virtual capability, but then having to emulate on top of that could and will create a significant performance tax. That's sort of an exponential tax. And as you think about virtual solutions, you want to be aware of those types of things and work around that. Just throwing your favorite container on it and hoping for the best is not going to yield the results you want. Relative to the big players that on Intel, VMware, for one, they obviously, as alluded to earlier, have a Fusion product that they're working for on the platform with regards to ESX, and with vCenter, we currently, and again, I'm not a rep of VMware, but we use them a lot. are not aware of any plans for the M1 platform or a roadmap for that product line. So if you are in that bucket and thinking about M1, you might want to think about how you're going to address that problem moving forward as ARM becomes the dominant architecture. Again, like I said, several of you probably use Anka. They're a Mac OS based virtualization. They too are working on the M1 problem. They too do not have a solution yet. And as I said, the Orca team here is obviously dedicated and interested in solving this problem as quickly as possible. We will be leveraging M1. We will be leveraging it before the end of the year. So let's talk about wrapping this all up into something that makes sense for everybody and coming up with some strategies to help you sort of stay ahead of the curve. Again, it's fine to say I'll just sit and wait and once everything's perfect, jump. You can do that. However, it's going to be a big uplift no matter what you do when you do that. And I would really recommend getting ahead of things. So one of the things that we think makes a lot of sense is start with a mixed environment. It's going to give you a really good look at the capabilities you have today and be able to compare them to ARM. Because again, not only is this about getting your stuff to work on ARM, but it's also seeing what capabilities and what performance metrics and profiles you can get out of this new hardware and this new platform. So I would adopt a strategy that allows for an environment that has both of these in it. And if possible, run your builds yourself or with someone like us so that you can start getting used to what you could do on both targets. You need to especially kind of dig into your CI/CD plan. That stuff's always changing anyway, and there may be efficiencies or benefits that you could leverage in your CI/CD pipeline or in your CI/CD tooling as you convert from these platforms that improve your overall CI/CD process regardless of M1, Intel, etc. And it's a good opportunity to start having a reason to inject those changes. Look upstream to communities like Docker, like us, like your favorite tool chain. See what they're doing, see where they're stuck, see what they want to do next, and quite honestly, give them your feedback and give them your notes. They are trying to solve this problem, but they also don't know everything they don't know. They're going to make the core of the tool that they have work. But if there are, edge cases, use cases that you have that are specific to your tool, it's really critical for you getting on the M1 platform to provide those and be vocal about that so that folks know what you're looking for. And again, begin designing your universal apps now. Begin converting your apps to multiple targets today. Start seeing what libraries and what dependencies might or might not cause you problems and how to convert those as quickly as possible. Because the sooner you're going to go native, the sooner you're going to get those bumps out of the way, but you're also going to get the maximum advantage out of this new hardware and this new platform. And it's going to prevent a lot of panicked mass conversion effort later if you start now. So what do we need to do? CI/CD tooling, right? It's improving the nature of your dev process. That's the definition of this agile process that we go through all the time. So again, look at all the components in your pipeline, look at all the build steps, look at all the ways you're packaging things, look at all the ways you're assembling your code on these various platforms. I think you may find that as you start to move tooling to M1, there may be opportunities to improve your tooling in general. And again, that's by looking at this transition as an opportunity to evaluate some of your legacy parts of that tooling. There's probably things in your build or in your pipeline that have worked for a long time and may or may not be the most efficient thing, but no one's really had a reason or need to touch them in a while, and this is an ample opportunity for that. See what works now too. Again, I would encourage everyone to, even if it's a complex app, fire it at an M1 sooner rather than later and figure out where the broken parts are. It could be as innocuous as a couple of dependencies in your code that you can easily fix and make quick work of, or something that you could emulate surprisingly well right now, and that would get you on platform faster. Or you may find that there are a lot of upstream and third-party dependencies, and that's also critical to sort out too, because that's going to help you more accurately dictate your timeline to migration, because you're going to be able to figure out where the upstream breakpoints are, who to focus on, get their feel for their timeline, and potentially help them drive that faster if need be. So, and in the spirit of that, that's going to get you hooked in to be able to support and contribute features, testing, etc., to that preferred tooling and get it adopted faster. If you sit quiet and wait for it to get done, it will get done. It just may not have the impetus that you're expecting it to have. So you can kind of control your destiny there by forcing the conversation. And then leverage these new capabilities. You know, in addition to being a new platform, a new architecture, Apple's really put a lot of things, if you start looking at what they've done and what they've added and what their vision is, this platform in general has capability beyond the current hardware you're on. It has a whole different set of capability. And even with emulation, you can start seeing how these things work and what's going on. And it's a good opportunity to leverage that through testing and through use. So, you know, that's kind of our recommendation. We'd like to keep this conversation going. As MacStadium, again, this is all we do all day. We focus on Apple. We use Apple. We're adapting Apple to our community, and it is our business. So we're going to continue to focus on this problem. We're going to continue to stay active in the communities everywhere, in all the tooling, especially CI/CD, which is what we care about. And we have a MacStadium Slack channel. We'd love for you to join us there. We're going to share links. We're going to share findings. We'll keep you abreast of all the things that we know are ready and active. And we're also going to blog and recap everything so that you have a good place to get summary. But our MacStadium community Slack channel, hashtag M1 Mini channel, MacStadium, right here you can see it. We'll provide the links out. We want to hear from you, especially whether you're a customer or not. We'd love to see what's working, what's not. And again, as we do R&D and as we figure out the solutions to these problems, we're going to be as transparent as possible. And the more you provide as input, the quicker we all can get there. So just a plug for us here at the end. If you want to get started with a mini, obviously you can get M1 now. We jumped on it as soon as possible because we believe it is our future, and we have them available in the US and Europe. You can get them in different specs. You can get them online as individual machines, but we'd love to actually set you up with a cloud so you can really engineer your build process and how you would orchestrate a large scale build. So if you want to do that, talk to our sales folks, and you can chat with us online as well. So with that, I'm going to take a breath and open the floor up to any questions. I am happy to share anything I may know and see what kind of ideas you guys have about M1.
Great. So go ahead and submit those questions in the questions pane. I do have one question currently, Chris. So that would be, and I think that you may have already covered this, but what is the best resource for figuring out what will run on the Mac, run on the M1?
Yeah, so there's actually a couple of really cool folks out there that as soon as it dropped, started testing any and everything they could get on it. There's some how to ARM, will it ARM site. There's a couple of blogs. There's a really good, and I'll have to go back a few slides to find it, a good link, and we can provide all these links out. But these sites provide a really nice red light, green light view of M1 and the M1 architecture. And again, they kind of test everything that's not a native Mac app and give you an idea of whether it runs emulated or whether it runs native, and they try to do their best to keep it tracked. And if you have one that you want to know about, you can submit it and they'll test it.
Very cool. I'm not getting any more questions. If we want to give it just a minute or so, we can, or we can wrap it up.
Okay.
Here we go. One came right in. So re-imaging dead. How is MacStadium dealing with this for your M1 offerings?
That's a good question. With a lot of research at the moment, but also we have some processes on how we stack our capacity and how we rotate it and how we reset the host. It's not ideal and it is not what we hope to do long term, but it does allow us to at least have a a solid planning and manual process around getting the host reset, although it's not instantaneous or as fast as we'd like. So, you know, short answer is we have some tips and tricks on how to get the host back to a ready state as quickly as possible. We have very skilled data center techs, and we have a capacity plan for our M1s so that we have sort of over capacity that we need to kind of swap them out. So if one's being swapped out, we can swap one in, and that's how we're dealing with it now. We're also working with our partners, and we're asking product questions to Apple to see what they recommend as guidance there. And I think we're getting some feedback and solutions from that direction as well, but we'll have to keep you posted as those come in.
Great. It seems that we don't have any more questions after that one. So with that, oh, actually, spoke a little too soon. How about auto install of Rosetta 2?
As in, I'm assuming they mean how about having Rosetta 2 auto installed on the host? Yeah, we can certainly enable Apple software to be available on the Apple host, but again, MacStadium's stance with regards to Apple software is that we don't want to get between you, the customer, and Apple in a relationship there. So oftentimes we'll want the customer to load any software that requires agreement to Apple licenses. It is possible now with the EULA to provide Apple in a state as long as the user agrees to the terms and the user agrees to Apple's terms. So, you know, it's definitely possible to make sure you have a Mac in the state you want it. Yeah, I hope I answered that correctly, or that was the way that question was supposed to go, but that's there you go.
I have another one that just came in. Is M1 fully supported with Orca virtualization? Is there any known missing features?
So Orca does not support M1 currently. The Orca architecture right now relies on a base OS that Dockerizes the Mac OS and runs across the platform. There are obviously several keywords in that architecture description that cause problem or pause on the M1 architecture, one being Docker, the other being beneath the OS. So there are several limitations to virtualization and to the way we Dockerize our components right now that we're working through. We do have a roadmap and a plan for this. We are currently and actively working on M1 with Orca right now to solve the problem. It is not available today right now.
Are there any known virtualization solutions that work for CI/CD today?
Good question. Not off the bat, no. Again, you can do Linux virtualization or Linux VMs on the Mac M1 platform, and you can do a experimental version of 64-bit Windows in parallels. So if you had something that might work in those instances, you could try it out. Everything else is trying to figure out the right way to leverage the hypervisor framework on the OS, or to figure out the right way to interface virtualization to the platform. So currently virtualization is gated and folks are working to solve the problem.
Great. That seems to be all the questions that we have. Thank you for joining us today. To stay up to date on our last one. Last two. How does the virtualization roadmap look like in terms of timeframes? What are the biggest hurdles for getting M1 virtualized on an M1 host?
Time frame, realistically at this point, is probably second half of the year, late Q3, Q4, I'm hoping. Some of the biggest obstacles are capability, or is it even possibly capable of virtualizing the Mac OS on the Mac OS with GUI, and how does that work from an ARM architecture perspective? the ability to pass through native layers. When you talk about virtualization, it's one thing to virtualize the OS. It's another thing to provide the OS the necessary resources to do things that we often do in builds. And you know, a build could be anything from a simple checklist application to something as complex as a very robust game. So you start to think about things like SMC and GPU. You think about platform resources in general, and figuring out what we can and can't do with those resources is a big obstacle at this point. So those are things that have to be solved for virtualization to work, not only work, but work well for build and for build products.
Fantastic. Can you boot Linux on M1 Mac?
Yes, is the short, direct answer to that question. Again, I alluded to Marcan as the handle you'll see on the web. You'll see articles out there about Ubuntu. You'll see a company called Corellium, who were previously, they're a security focused company, but they've worked on ARM architecture before. The Linux community was obviously as excited as everyone else about the hardware. That said, you know, obviously that's not Apple's intention to have someone else's OS run on their hardware, but they have made rapid and great strides to the M1 platform, and there are instances of fully functioning Ubuntu desktops running out on the wild, both on the laptop and on the M1, and on the Mini. And there are continued works with groups like Asahi that do GPU research and GPU drivers. The Linux community is basically making sure they can write the drivers and capabilities that they can leverage the platform with and for. So it is possible. It is crazy early days with that. And also, you know, if I'm being honest, it depends on what Apple wants to do next as to how well that works. But there are components of that that aren't blocked by Apple, and I don't think, again, that they care one way or the other to block or not block. They care about making a good product. But the ability to have different bootloaders work is important. Aside from putting Linux on a Mac, that's something that just happens to be able to be done. But it's more important for how we proceed forward with virtualization, with isolated processes, for things like that. So there's been work actually contributed by Apple that enables the boot process to work correctly to allow things like this. Again, I don't think that's something they're necessarily focused on or intentional one way or the other, but it's certainly not something they're interested in blocking. And it's always good to note that there's a secure part of the startup process that is always a closed system that is always protected, and then hands off to these bootloading systems after the fact. But that is the long exposition on the short answer of yes, you can actually put Linux on a M1 processor at this point.
And one more, has anyone gotten hardware-driven Android emulation working on an M1?
People have made it work, and I will put that in bold, italic, heavy air quotes. It is not something you would want to do at all, because it is kind of that emulation virtualization double triple Lindy thing I kind of referenced earlier in the deck. It just comes with this compounded penalty, plus it's not written or optimized for the platform at all, so it runs, quite frankly, much worse than it would in other situations. So it is not ideal right now, no. But it is technically possible. It's just not usable.
Great, and that is the last question that we have, so I'm going to close it up for now. Thank you all for joining us today. The video of this webinar will be available in the next few days. To stay up to date on our webinars in the MacStadium blog, be sure to join our MacStadium community Slack and follow us on LinkedIn, Twitter, and Facebook. Thank you guys so much, and thank you, Chris.
Thank you.